course, in the last years and decades, this has increased a lot, but it has always been that way. We exchange information with other parties. We exchange a virus with another human being. It has always been about people or nodes interacting with other parties, people. And everything, basically in this world almost, could be represented as a graph. And a graph is a really simple object. It consists of a node. It could represent a human being, which could represent a computer. And these nodes are connected by edges. And this can be, for example, if I follow someone on Twitter, or if I have a friendship on Facebook, I'm connected to someone. If I exchange information or a message with someone, I'm connected to this node. And in a graph, there can be also certain subgroups that are closely connected. And to them we refer as clusters. So in there is everything that we need to know about interaction. It's called a graph. And every node is nothing in and of itself. A node is only defined by the interactions that it has with others. And there are different types of nodes. For example, if I follow someone, this is a one-way interaction. I just follow you on Twitter. I just send you a message. I pass on the virus as a direction. But there are also undirected ones. When we're in a friendship, this is a hopefully mutual thing. And also, it might not be even that. It could be that the edges are weighted. I could like you more than you me. It's often the case in dating, until you find someone that's balanced. So there are different types, and we are defined by the interactions that we have. So I already mentioned it can be computer networks, computers talking to each other. It can be biological problems, but for the remainder of the talk I will refer to humans interacting in a social context. But it can be extrapolated to anything. So in order to deal with that in a mathematical way, we have to translate this graph into numbers. And an obvious way to do that is to display it as a matrix. So we see we have 5 nodes, 5 people here, and we arrange them in a grid. And whenever 2 people interact, which is depicted by the edge, we put a number there that kind of tells us how much they are interacting. You see, A and B, they have a thick edge between those two, so there is a 1. A and C, they have a somewhat thinner edge between those, and there is 0.25. So it could be that they exchange fewer messages. Could be that A is reading a lot of messages of B, but not of C. And there are nodes that don't interact at all, which have a 0. It could even be nodes that hate each other. It could be a negative number. And from this simple data, it's called an adjacency matrix, we can extract a lot of information. I told you that the node, the person, is defined by the interactions that it has. And there are many different ways now to measure what are you, how important are you. For example, someone sitting in the middle here, like the spider in the web, and everyone just talks to them. There's a lot of power in a sense, because he is the hub that connects all the rest. You listen just to one. It could be also that I am not connected to anyone, but I'm connected to a very important person. So this importance of the person kind of translates to me, because I can talk to the American president, so I have a lot of influence. I don't have to talk to millions of others, just to one. And there are different ways to measure these importance. So one is, a simple one is just degree. How many connections do I have? Everyone is hunting for connections on LinkedIn. They're trying to improve their degrees in neutrality. Closeness means, am I at the center of a network, or am I outside of a network? How fast can I spread the message? If I want to get a new post around the group, I need to be in the middle, not at the very edge. And betweenness is another one. There are countless ones, but betweenness is another one that's important when you are between 2 important parties, or between 2 clusters of a group. Especially in a company, you have these problems that there are only a few points of connection between teams, and they are very important. So we looked at, or it really was a coincidence to look at this use case. So one day, my mom, who is a teacher, we were just talking casually, and she told me, well, today was the first day at school, and I asked my students, like, whom they like, whom they don't like, and we have written that down. And I was like, she didn't know what I was doing basically, but I was like, Mom, that's awesome, can you send me that data? So she did, and this is the network of interactions that came out to be. That's her class. And I, without talking further with her, I started analyzing that. So please, the next slide, don't take a photo, it's really like the personal data of those guys. So first of all, I did a page rank centrality measure on it, and this is something that I already mentioned, is when I'm connected, it's basically also the algorithm that Google used in the beginning. When I'm connected with people who are important, that makes me important. So people talking to important nodes get some kind of importance from them. And basically those students were only asked to name up to 3 people they like and up to 3 people they don't like. Which is actually, I don't know, I think it's quite questionable to do that, but they did nonetheless. And I got this graph, and I said, well, Mom, when I talked to her again, I think this is the class representative was right. And I talked about a lot of other things. For example, you see these 2 groups. And I said, well, Mom, I think that this group is kind of the light side grouping around the class representative, and this is more like the dark side. I said, yeah, they're probably more the troublemakers over there. That's true. How do you know that? And this one is the leader of those. So you can extract a lot of information out of that. Another one that's important, like when I do the betweenness one, suddenly those nodes connecting to those 2 groups become important. Because when you want to send information to another group, if you want to do group activities, if you want to go on a vacation with the class, you need to have the whole group together. So you need to have those to communicate between those 2 groups. And this is basically something that can be sourced from any kind of data. If you want to, like in a company, you can use email data, email interaction, and do the same thing. And you see in a big organization, where are the bottlenecks? Who is important actually? Some people you might not even think they are, or who is like a bridging point between groups. But this wasn't the case of a classroom. And we also, of course, did clustering of groups, and we got 3 subgroups out of that. And from this graph, I created a seating plan for the class, and it was, as I was told, the best one that has ever existed. No one was complaining. I mean, people's always complaining, I don't want to sit between those 2, and I want to sit there. This time, it was fine. No complaints.
Is it always the same?
It's always the same.
You're just basically clustering or analyzing the
correct.
Importance according to the KPI.
Correct. So here it's even the same structure, it's just different weighting of the nodes.
Yeah, exactly.
And here it's the same people, it's just differently arranged. Yeah, exactly. And when we have done that, we can even go one step further, not in the classroom example, but in the example of communication, to analyze what's actually sent between those nodes. What's the meaning, what do the people want to say when they send an email? It's not just about interaction. Of course, interaction gives away a lot of information, but there is also information in what they send. And nowadays we can analyze that. And it started out many years ago actually by labeling words. For example, we wanted to know, are the people feeling good about something? Are they feeling bad about something? Just label the words. Well, happy is probably plus 1.1 and angry is probably minus 2.3. And then they just count the words and they get a number. And this has improved with machine learning. Obviously, I want to talk about one approach that's used nowadays, but it basically boils down again to having to translate text or words into numbers. And the easiest approach to do that would be, I have a dictionary like that, and every word has a place in the dictionary, and then I have a vector, which is just a collection of numbers, and I put all zeros in this vector, except for the word that I want to represent. I put a 1, and I have a vector of long zeros, and a 1, 1, and this is then, for example, the orange, second place in the dictionary. But of course, this is a bit inefficient, so people came up with other ideas, and one is called glove. There are really many. Another one was even shown by Mark before, it's called word to vec. But glove is one where they basically take a huge amount of text and look if a word is often co-occurring with another word, for example, ice and water. And what they then do is they just give each word a random vector, with random numbers in it, and then they try through an iterative process to, basically it's a bit technical, but they try to minimize their dot product. But what in the end, what comes out of the whole thing is that we get vectors, which are things that have a direction and a length. And the direction and the length have meaning. And you can see that here, you translate like the meaning of a word into a geometrical space. For example, you see the relationship between man and woman, king and queen. It's the same vector. So I can add the vector to man, get woman. I can add the same vector, I get the queen. This makes sense. I have a vector that gives me the CEO. I can even start asking questions to this database. I can say IBM plus the CEO vector, and I get the name of the CEO. Or the same with zip code. I have the zip code, I add the zip code vector, and I get the name of the city. Or for the superlative of the adjective, it's the same. So we get information in a geometrical space. And these vectors can be fed into any kind of classification algorithm. Usually we use neural networks. And what we can do then with that is measure sentiment on a large scale. For example, this one is from Marco Rubio, has been done for many years, just analyzing with the same technique, tweets, articles about this guy. It gives you a volume, like how much is going on, how many people are talking it, and also sentiment. Here it's rather positive, here it's rather negative. And we see when he announces he will run for president, there is a huge surge of interest here. And also people are quite positive about this guy. And then, you know, other candidates came, it got a bit more quiet, also the sentiment went down a bit. I think then few candidates emerged and the battle between him and Trump started to get traction until he said, okay, I'm gonna leave, I'm not gonna run against this guy, which happened here around April 16. So what this enables us to do, basically, what do we want to say with that is, we can now really gauge the opinion of networks interacting with another on a large scale. And I can do that for many different things at the same time. And this gives me, for example, the possibility, if I go back to that, when I'm writing a newspaper article, I can track how people are feeling about that, or even feeling about a certain topic, and can say, well, there's not a lot of going on with Marco Rubio at this point. Let's write an article about Trump, for example. Or as a company, if you have a marketing campaign going on, you can gauge how people are feeling about that. You can use this as an input to basically anything, to trading algorithms, to getting insights into groups, as I've shown before. If I have more data, if I have data, for example, about chat messages that these students send, I could even get a more fine-grained picture. And yeah, by that I want to conclude. Thank you very much for your attention, and on to the next talk.